This video will discuss the formation of the solar system, and a different video will talk about exoplanets. But let's go ahead and take a look at what data we have to base a hypothesis on, observations that have been made in our own solar system. We have the 8 planets. They're basically in a disk, and this disk is above the equator of the sun, around the equator of the sun. The planets' orbits are nearly circular. There's some eccentricity, but nearly circular, and the planets all orbit in the same direction that the sun is spinning. The inner planets, as we've talked about before, lack the hydrogen and helium. The outer planets have abundance of hydrogen and helium, and some planets are miniature solar systems, especially Jupiter and Saturn have a satellite system of regular satellites in the plane of their equator. The planets have 90% of angular momentum of the solar system. This angular momentum is a quantity that sort of governs how fast an object spins. When an ice skater pulls in his or her arms, they spin faster. This is conservation of angular momentum. As mass is towards the axis of rotation, the object will spin faster. If the mass is away from the axis of rotation, it will spin more slowly. So there must have been some mechanism by which the sun transferred angular momentum to the planets. If the sun had kept all of its angular momentum, this rotation quantity, it would spin a lot faster than it is now spinning. So the planets have accumulated, have been the recipients of a transfer of angular momentum from the sun. And of course the sun dominates the solar system. Well, what are some models of forming the solar system with our planets? A collision theory, the collision model. Maybe another star hit the sun and sort of scattered off debris from the sun that then condensed and formed the planets. Well, there's a lot of space in space. If you take your little finger and you would look at the size of your fingernail, and if this was the size of the sun, roughly the nearest star to the sun would be 250 miles away. Collisions between stars are very unlikely. The stars are small compared to the distance in between the stars. And there would be problem in obtaining circular orbits from the condensation that broke away from the sun. So astronomers are discounting the collision model. It does not agree with our observations. The fission model. Perhaps the sun was spinning more rapidly in the past, and it broke off mass, gas of coming off, dense gas. Well, it's the speed that the sun would have to be spinning is too fast. And it's not easily seen how the sun could get up to that rate where it kind of almost flies apart. And it does not explain the difference in the composition of the terrestrial and the gas giant planets. So that model's not so good. The condensation model. Suppose we have a large gas cloud of hydrogen, helium, and trace elements of the heavy elements, trace composition of the heavy elements. It becomes dense enough for gravity to cause it to collapse. It's getting denser, gravity is getting stronger, more effective, and it collapses, and it's conserving angular momentum, so it spins and forms a disk. Rotating systems naturally form kind of a pancake shape. That's why Saturn has its rings that are very thin as compared to their diameter. We get this disk shape spinning around the central object in its natural formation. The sun is forming at the center, very hot, very massive, but in the disk we have material moving sometimes up, sometimes down through the plane of the disk. And if these collisions are not too rapid, too much speed, then the particles can build up. The grains of dust that are in the nebula can gather together to form pebbles. The pebbles gather together to form planetesimals. The planetesimals merge and form the planets. With a high temperature near the sun, these inner planets would lose hydrogen and helium. Those gases would move too fast to be retained by the gravity of the planetesimal or the planet. So this condensation model again, pebbles to planetesimals to planets. We build up planets from small objects, and this whole disk is spinning around the sun. So those planets that form from the material in the disk are going to have the same spin direction and orbit direction as the spin of the sun. The rotation axis spin is going to be the same as the orbit direction going around the sun, and the sun is in that same sense rotating. The high temperature near the sun caused these inner planets, the terrestrial planets we call them now, to lose hydrogen and helium. The outer planets are colder. The hydrogen and helium gases are moving at a slower speed and can be retained, and those planets build up a big mass. And the outer solar system, we have ices forming, cold, and the hydrogen, helium, and other trace elements form ices. So here we have an example of photograph of an interstellar cloud. As the radio astronomy can inform us, there are molecules in these clouds, and gas and dust, and we're getting a compression here as the for various reasons. We might have a supernova exploding someplace, and that pressure wave push here and compress these gases, or light can press in on the cloud, and it's getting ready to form stars and solar systems. It's becoming dense enough that the self-gravity is pulling parts of the cloud closer together. Dust ring and ice ring. This is a drawing and not an actual photograph, but just illustrating what's happening here in the process of forming the central star. And we have dust closer to the star, ices further away from the star where it's colder. And here the dust is starting to be cleared out. Stars go through a phase where they have outbursts of light and pressure pushing dust away from the inner solar system, kind of clearing it out. And it'd be nice if there were other planets like Saturn. This particular artist really prefers Saturn to other style of planets, I guess. So how would we search for planets around other stars? And with this, we come into the exoplanet method, and I'm going to save this for another video, but just to go back to where we are here, the astronomers believe the solar system formed by a gas cloud collapsing, and there's condensation to pebbles, to planetesimals, to planets, and that resulted in a disk of the primary planets in the equator of the sun, spinning in the same direction the sun spins, orbiting the sun in the same direction the sun spins. So that's our current theory for the formation of the solar system, the condensation model.